Good morning, scholars, and welcome back to another day of math learning. Our focus today is going to be subtracting a fraction from a mixed number, okay? So in order to effectively do this, we want to refer to our criteria for success. So the first thing we want to do is we want to make sure that, if possible, we're going to try to subtract the subtrahend from the minuend, okay? I'm going to stop here just to get you to gather your thoughts on that math vocabulary. When I refer to subtrahend, what do I mean? When I refer to minuend, what do I mean? Okay, and 5, and 4, and 3, and 2, and 1. Alrighty, so our subtrahend is the number that we take away from the minuend, right? And the minuend is our greater amount. It is the first number, okay? Now, let's say we can't just simply do this, then we're going to push further by decomposing the subtrahend. And last, we want to make sure that we're showing our work, and we can check our work using a number bond or a visual model, okay? So let's get started. All right. So if we were to rewrite 4 3/5 the way we were thinking about it last week, I would say all it is 4 plus a fractional part, which is 3/5. However, in this case, if we are subtracting the subtrahend, which is 1/5, okay, automatically I see that, well, this is definitely greater because it's paired with a whole, but if I'm only subtracting 1/5 away from it, it's pretty simple, friends. This is an example of subtracting the subtrahend from the minuend fairly easily, I should say. And so what I'm going to do here is I'm going to start off by thinking to myself, well, do I need to touch the whole number? Not really, because if I'm taking away 1/5 from 3/5, it's like taking away 1 from 3, right? I subtract 1 from 3, I get 2, right? Very similar. So my 4 remains untouched. I'm just going to carry it over to our difference, and then I'm going to think to myself, well, taking away 1 from 3 gives me 2, and so 2/5. So this is an example, again, friends, of a fraction that does not need to, where I'm not touching the whole, and I'm just rewriting the whole, and all I'm doing is subtracting 1 from 3. But I did say, in order just to guide my thinking and check for accuracy, I also want to try to do this another way, and I'm going to offer a number line for this example. So in order to subtract using a number line, I have to think to myself, well, I'm going to refer to my minuend, right? I know my minuend is greater than 4, so my whole number that I'm going to start off representing is the whole number up. So not 4 versus it should be 5, right? And then if I'm only subtracting 1/5, well, 1/5 is less than what whole number, right? It's less than 1. And so I'm going to, on my number line, show 5 and 4. Those are my two whole numbers that are going to help me represent this problem. Now, I'm also going to want to, at the same time, I'm going to want to partition my number line into, you tell me, into thirds, into fourths, into fifths. Ding, 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 you got it, okay? So let's do this. This is 1/5, 2/5, 3/5, 4/5, and 5/5. If I wanted to relabel this, though, so that I can accurately show my work, this would become 4 1/5, 4 2/5, 4 3/5, and lastly, 4 4/5. Because this is simply just 4 5/5, which is essentially 5, the same thing, right? Alrighty. So again, starting point, my minuend. Let's find 4 3/4 on this number line. Okay, and since I'm subtracting, am I going to go forward or am I going to go backwards? Ding, 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 you got it. Yep, backwards. All right, and I'm going to go backwards. I'm going to subtract just 1/5. That means one jump, right? If each of these partitions represent 1/5, all it is going back 1/5, which gives me a difference of 2/5. Okay, and so this is an example. Again, we did not have to decompose the subtrahend any further. And we did use a number line to kind of check our work and represent our work. All right, so stay tuned because I do want to show you another problem that is a little bit more challenging.